Welcome to this Chemscape video on chemical glove selection. There are many options for selecting a glove, and it's important to understand how to choose the correct one for your task. In this video, we will focus on chemical-resistant gloves. Chemical-resistant gloves are tested in laboratories for permeation and degradation. These tests determine how chemicals interact with glove materials. Your skin is a major entry point for dangerous chemicals into your body. Chemical exposure can cause cancer, genetic damage, burns, and skin sensitization. Chemical skin exposure is one of the most frequently reported workplace incidents. Choosing the right glove requires an assessment of your specific hazards. An assessment evaluates the hazards encountered on the job, the chemicals being handled, and the frequency and nature of contact. Penetration happens when chemicals flow through holes, tears, or seams. These imperfections may be invisible to the naked eye. Degradation occurs when chemicals physically deteriorate the glove material. Signs include discoloration, hardening, softening, swelling, or dissolving. Permeation is when chemicals pass through materials at the molecular level. This process is completely invisible and happens over time. Breakthrough time measures how long chemicals take to penetrate completely through a glove. This tells you how long your glove will protect you. Chemical-resistant gloves undergo rigorous laboratory testing. Always follow manufacturer recommendations for your specific hazards. No single glove material resists all chemicals. No glove remains impervious to any chemical forever. Begin every glove selection with hazard identification and risk assessment. Know exactly what chemicals and hazards you'll encounter. Section 8 of the safety data sheet may recommend appropriate glove materials. Contact the manufacturer or glove supplier if the glove type isn't provided. Gloves that are used for direct contact or are immersed in chemicals will need to be higher quality than those used for splash protection. Consider grip, flexibility, and touch sensitivity needed for your work. These requirements may limit glove options due to thickness and fit. Incidental contact involves little to no direct contact with the chemical. Examples include accidental spills, splashes, or overspray protection. Extended contact includes handling contaminated materials or submerging hands. These situations require more substantial chemical-specific gloves. Don't forget mechanical hazards like cuts, tears, and punctures. Environmental factors like heat, cold, and radiation also matter. Chemicals react differently at elevated temperatures. Heat can accelerate permeation through glove materials. Glove manufacturers provide selection charts and software tools. Independent sources like Wiley also offer compatibility guides. Always inspect gloves before use for rips, punctures, or contamination. Look for signs of degradation like color or texture changes. Replace gloves immediately when degradation signs appear. Always keep suitable replacement gloves readily available. Practice putting on and removing gloves as part of your training. Proper technique prevents contamination during removal. Clean gloves go in regular disposal. Contaminated gloves require hazardous waste procedures. Always wash your hands thoroughly after removing gloves. Include drying and moisturizing as part of your routine. Never take work PPE or gloves home with you. Store separately from all personal belongings. Always start with elimination, substitution, and engineering controls. Use gloves only when other control methods aren't sufficient. Safety data sheets are constantly being updated with new information or as product formulations change. Regularly review the chemicals you work with for skin hazards at your location. Protect yourself wisely and take all measures to reduce exposure. For more information, consult your health and safety representative.